Friends, today we are solving NEET model questions on alcohols and phenols. Given the first question is the catalytic hydrogenation of a primary alcohol gives primary alcohol undergoes catalytic dehydrogenation. Here, the catalytic dehydrogenation process takes place in the presence of copper at 573 kelvins. If 1 degree alcohol undergoes catalytic dehydrogenation, then it gives aldehyde as a product. If it is 2 degree alcohol, then it gives ketone as a product. If it is 3 degree alcohol, instead of catalytic dehydrogenation, dehydration process takes place and it gives alkene as a product. Here the question is related to primary alcohol. Primary alcohol undergoes catalytic dehydrogenation, then it gives aldehyde as a product. See the next question. In Lucas test, primary, secondary and tertiary alcohols are distinguished on the basis of their reactivity with concentrated HCl plus ZnCl2 known as Lucas reagent. Yes, statement 1 is correct, no doubt. Why? Because Lucas reagent is a mixture of concentrated HCl and anhydrous ZnCl2. Statement 2. Primary alcohols are most reactive and immediately produce turbidity at room temperature on reaction with Lucas reagent. Second statement is not correct. Incorrect statement. Second statement. Why? Because 3 degree alcohols reacts with Lucas reagent, then it gives turbidity immediately. If it is 1 degree alcohol, no reaction takes place, turbidity does not formed. So the correct answer is third option. Next question is acetaldehyde reacts with Grignard reagent. We know that aldehydes are favorable towards nucleophilic addition reactions. First of all, break the bond between alkyl group and magnesium. Alkyl group gets negative charge, magnesium gets positive charge. Nucleophile is moves towards carbonyl carbon side, then pi bond is moves towards oxygen side. So the formed product is CH3, CCH3, hydrogen, OMgBr. Which on further hydrolysis O minus Mg plus H2O dissociate like H plus OH minus. Remove MgOHBr. MgOHBr you can remove, then it gives CH3 CH OH CH3. Reacts with the concentrated H2SO4. Concentrated H2SO4 acts as dehydrating agent. Dehydration process takes place. Remove water molecule. Dehydration follows beta elimination. So remove hydrogen atom from beta carbon. Then it gives but1ene CH3CH double bond CH2. Further, it reacts with the B2H6 H2O2 OH minus. This process name is hydroboration oxidation. Hydroboration oxidation follows anti-Markovnikov's rule. Add water molecule, follow anti-Markovnikov's rule. Anti-Markovnikov's rule is add hydrogen atom from H2O, to unsaturated carbon which contains less number of hydrogens. Then the compound is CH3CH2 CH2OH. So this is A and this is C. A and C. A is propane 1 ol and C is propane 2 ol. Correct answer is first option. See the next question. Which statement from the following is true? Esterification. What is esterification? Alcohols reacts with carboxylic acids or acid chlorides or acid anhydrides. Then it gives esters, and this process is called as esterification. In esterification process, remove H plus from alcohol and OH minus from carboxylic acid. Then it gives RCOOR. Ester is formed. Which is true during esterification? OH minus from acid molecule, H plus from alcohol molecule remove. So the correct option is third option. See the next question. Phenol reacts with NaOH. Phenol is a acid, NaOH is a base. Acid-base reaction takes place. Remove H plus from phenol, OH minus from NaOH, then it gives sodium phenoxide. Sodium phenoxide reacts with CO2. We know that CO2 is a weak electrophile. Further acidification, then it gives salicylic acid, and the reaction name is called as coal-base reaction. Then it gives coal-base reaction. It gives salicylic acid, OH, COOH. This reaction is called as coal-base reaction. Now, salicylic acid reacts with the acid anhydride. Salicylic acid reacts with acid anhydride. The process name is called as esterification process, and it gives here alcohol group is reacts with acid anhydride, then it gives ester. O COCH3 COOH. Aspirin is formed. Aspirin name, common name is acetyl salicylic acid. From here to here, the process is called as esterification. We know that esterification process case, alcohol loses H plus ion, CH3, COOH. Substitute COCH3 in place of hydrogen, then you will get aspirin. So the correct option is second option. The next question is methanol is industrially prepared by. Methanol is industrially prepared by hydrogenation of carbon monoxide at high pressure and temperature in the presence of zinc oxide Cr2O3. Methanol is formed CH3OH. Next question. Reactant reacts with NaBH4. We know that about NaBH4. NaBH4 is a selective reducing agent. It is a selective reducing agent. It reduces aldehydes and ketones without affecting any other functional groups. Reduces aldehydes and ketones without affecting any other functional groups. We know that this is which group, Amma? Ketone group. Ketone group undergoes reduction, then it gives alcohols. Ketone group undergoes reduction, then it gives alcohol. What about the next functional group? Next functional group is RCOOR. This is the ester functional group. Ester functional groups not reduced by NABH4. So the correct option is second option. Option is second option. Only ketone group is affected. Ester group is not affected. See, the next question is matching type of question. CH2OH, CHOH, CH2OH. First compound IUPAC name is propane 1, 2, 3 triol. Common name of this compound is glycerol. Benzene 1, 2 diol. Common name of this compound is catechol. Ethoxybenzene. Common name of this compound is phenol. And ethane 1, 2 diol. Ethane 1, 2 diol. Common name of this compound is ethylene glycol. Ethylene glycol. So now you can check it. A is glycerol. A2. B is catechol. B1. A2 B1. So the correct option is third option. See the question. Among the following four compounds, phenol, 2-methylphenol, metanitrophenol, paranitrophenol, the order of pKa value. Question is related to pKa. We know that acidic nature is inversely proportional to pKa, and acidic nature is directly proportional to electron withdrawing group. Acidic nature is inversely proportional to electron donating group. First of all, identify NO2 group. NO2 groups are electron withdrawing groups. CH3 group is electron donating group. In case of phenol, no electron donating group or withdrawing group. There is no electron donating group or withdrawing group. So, which is least acidic? 2-methylphenol is least acidic. Least acidic. Because electron donating group decreases the acidic nature. We know that acidic nature is directly inversely proportional to pKa. So, correct option is fourth option. Least acidic, more pKa value. More pKa value. The next question is cumene reacts with oxygen. If cumene reacts with oxygen, then it gives cumene isopropoxide. Cumene peroxide. Cumene peroxide. The cumene peroxide further hydrolysis. Cumene peroxide further hydrolysis, then it gives phenol and acetone. CH3COCH3. Phenol and acetone. Phenol and acetone. So the correct option is third option. See the next question. Predict the nature of reducing agent in the following reaction. In this reaction, ketone group is converted to alcohol group, as well as alkene group is converted to alkane. So strong reducing agent is required. The strong reducing agent is H2 by Pt. So here remember nickel, platinum, palladium reduces, it reduce alkene and carbonyl groups. LiAlH4 and NaBH4 reduces only carbonyl groups. So the correct answer is third option. See the next question. Alcohol H plus by delta. H plus by delta. Here which process takes place? Dehydration process takes place. Dehydration process takes place. Dehydration. Okay. Beta carbon. First identify the beta carbon. Beta carbon is which type of carbon? Beta carbon is quaternary carbon. Beta carbon is quaternary carbon. So shift takes place. First of all, remove OH minus ion. Remove OH minus ion. Then it gives compound like this. OH minus is eliminated. So this carbon gets positive charge. This is which carbocation? 2-degree carbocation. 2-degree carbon, adjacent carbon is quaternary carbon. So methyl shift takes place. Methyl shift takes place before. Okay. See, before methyl shift, ring expansion takes place. Before methyl shift, ring is expanded according to Bayer's strain theory. Break the bond between carbon and carbon. One carbon gets positive charge, the another carbon gets negative charge. So attractions are developed between existing positive charge and newly formed negative charge. So this is the compound now. Attractions are developed. Here this carbon gets positive charge. Cyclic compound is formed. The cyclic compound 1, 2, 3, 4, 5, 6. 6-membered cyclic compound this is. You can draw in the form of a regular 6-membered ring. Yes, 1, 2, 3, 4, 5. At 5th position methyl group is present. 6th position also methyl group is present. 6th carbon contains positive charge. Now remove hydrogen atom. Remove hydrogen atom. Then it follows Sage-Jeff's rule and it gives alkane. What is Sage-Jeff's rule? Remove hydrogen atom from beta carbon which contains less number of hydrogens. Here 2 beta carbon atoms are present. First beta carbon contains two hydrogen atoms, but the second beta carbon, around this carbon already three bonds are there, so only one hydrogen. Remove this hydrogen atom according to Sachev's rule, so this is formed as a product. Correct option is first option. See the next question. Which of the following reaction will yield propane to ol? Okay, this is propane to ol. Propane to ol is a 2-degree alcohol because OH group attached carbon directly attached to two other carbons. So it is 2-degree alcohol. We know that formaldehyde. If the aldehyde is formaldehyde, formaldehyde reacts with a Grignard reagent which on further hydrolysis, then it gives 1-degree alcohol as a product. Except formaldehyde, any other aldehydes except formaldehyde, remaining aldehydes reacts with Grignard reagent which on further hydrolysis, then it gives 2-degree alcohol as a product. Suppose if ketone reacts with Grignard reagent which on further hydrolysis, then it gives 3-degree alcohol as a product. First of all, identify this is aldehyde. This is aldehyde but not formaldehyde. Except formaldehyde, remaining aldehydes reacts with Grignard reagent, further hydrolysis, then it gives 2-degree alcohol. So second one gives 2-degree alcohol. What about the third one? Third one is formaldehyde. It gives 1-degree alcohol. So third one is wrong. Check the first one. Alkene undergoes acidic hydrolysis. Alkenes are undergoes acidic hydrolysis. Follows Markovnikov's rule. Add hydrogen atom from H2O to unsaturated carbon which contains more number of hydrogens. Then CH3CH OH CH3. Yes, this is also 2-degree alcohol. So first one gives 2-degree alcohol. Second one is also gives 2-degree alcohol. So correct option is first option. Next question is phenol reacts with zinc test. Phenol reacts with the zinc test. Reduction process. This is a reduction process and it gives benzene as a product. A3. Phenol reacts with chloroform and NaOH. This is Reimer-Tiemann reaction and it gives salicylaldehyde. What is the reaction name? Reaction name is Reimer-Tiemann reaction. Salicylaldehyde. Salicylaldehyde B1 A3 B1. Third option is correct option. What about the next one? CO2 NaOH. Reaction is coal base reaction and it gives salicylic acid. Reacts with concentrated HNO3, then it gives 2,4,6 trinitrophenol. 2,4,6 trinitrophenol is also called as picric acid. The next question, which of the following reagents cannot be used to oxidize primary alcohols to aldehyde? We know that alcohols are converted to aldehyde means partial oxidation takes place. The partial oxidation is possible in the presence of PCC or PDC or CrO3, even catalytic dehydrogenation, copper by 573 kelvins. in the presence of KMnO4, then it gives carboxylic acid as a product. So cannot be used. KMnO4 in acidic medium cannot be used. The next question is pKa value of phenol is 10 while that of ethanol is 15.9. We know that acidic nature is inversely proportional to pKa. Inversely proportional to pKa. Ethanol is strong acid than phenol. Assertion is true, but reason is wrong. Which is strong acid? Phenol is strong acid than ethanol based on the pKa value. So third option is correct option. Arrange the following in the decreasing order of acidic nature. We know that acidic nature is directly proportional to electron withdrawing group. That means minus I effect inversely proportional to electron donating group. First of all, para position NO2 group. NO2 group is acts as electron withdrawing group. CH3 group is acts as electron donating group. OCH3 group is acts as electron donating group. Cl group is also acts as electron donating group with respect to resonance effect. But with respect to inductive effect, it is a electron withdrawing group. Now, CH3 and OCH3. OCH3 is strong electron donating group compared with the CH3. Compared with the CH3. Here, decreasing order of acidic nature starts with high. More is NO2. Third one is more. Only one option is there. That is the fourth option. Third after 1. 1 after 2. 2 after 4. 4 is last because OCH3 is strong electron donating group compared with CH3. Electron donating nature increases, then acidic nature decreases. See the next question. The compound that is most difficult to protonate is phenol. Is most difficult to protonate because what is the reason? The lone pair of electrons. The lone pair of electrons on oxygen atom are in conjugation pi electrons of benzene ring through resonance. See, how is it? This is phenol, lone pair of electrons. Because of its donating nature, it can donate. Immediately pi bond is delocalized. So resonance is possible. That's the reason phenol most difficult to protonate. Correct option is first option. See the next question. Butane 2-ol reacts with concentrated H2SO4. What is the role of concentrated H2SO4? Dehydrating agent. Dehydration process takes place. Remove hydrogen atom from beta carbon. Here two beta carbon atoms are present. So how many products are possible? Two products are possible. What is the first product? It follows Sage-Jeff's rule. According to Sage-Jeff's rule, remove hydrogen atom from beta carbon which contains less number of hydrogens. Then first possibility is CH3CH double bond CH3CH double bond CH3. This is the first possible compound. One more possible compound is remove hydrogen atom from beta carbon which contains more number of hydrogens. Due to one next compound. Due to one is the next compound. So product 1 and 2 are position isomers. Correct. Question is related to not true. It is true. Product 1 and 2 contains sp2 and sp3 carbon atoms. Okay. The yield of product 1 and 2 are same. No, not true. Third option is not true. Why? According to Sage-Jeff's rule, but 2-ene is major product. But 1-ene is minor product. So yield percentages must be different. The next question, identify X in the following sequence reaction. Okay. Copper 573 kelvins. Finally, what is the product? Product is alkene. Alkene is formed as a product. Means copper by 573 kelvins acts as dehydrating agent. When alkene is formed as a product, if the reactant is 3-degree alcohol, then it gives alkene as a product. Now, sorry, not 3-degree alcohol. If the reactant is 3-degree alcohol, 3-degree alcohol, then it gives alkene as a product. Now, 3-degree alcohol is formed. When 3-degree alcohol is formed, compound X is reacts with Grignard reagent for the hydrolysis. Already I discussed with you formaldehyde. If the reactant is formaldehyde, formaldehyde reacts with Grignard reagent. Further hydrolysis, 1-degree alcohol is formed. Except formaldehyde, Grignard reagent, then it gives 2-degree alcohol. When 3-degree alcohol is formed, if the reactant is ketone, identify. Now it is very clear X is ketone. Which is ketone form? This is aldehyde. So wrong. This is aldehyde. Wrong. Yes, this is ketone. So the correct option is third option. CH3CO CH2CH3. Ketones reacts with Grignard reagent which on further hydrolysis then it gives 3-degree alcohols. The 3-degree alcohol further reacts with copper 573 kelvins, then it gives alkene as a product. See the next question, which of the following statement is incorrect? Halogenation of benzene takes place in the presence of Lewis acid. Yes, this statement is correct. Lewis acid is required because what is the role of Lewis acid here? Because it generates electrophile easily. Halogenation of phenol takes place even absence of Lewis acid also. Yes, it is also correct because OH group is highly activating group. That's the reason highly activating group That's the reason Lewis acid is not required. Bond angle in phenol is greater than the tetrahedral angle 109 degrees. Wrong. Bond angle in phenol is smaller than the tetrahedral angle. Phenol reacts with bromine in presence of water, gives 2,4,6 tribromophenol. Yes, this is also correct. Here question is incorrect statement. Bond angle in phenol is greater than the tetrahedral angle. That is incorrect. See the last question. The intermediate formed in Reimer-Tiemann reaction is substituted benzyl chloride. Statement 1 is correct. Substituted benzyl chloride. Yes, according to this is NCERT textbook line. Substituted benzyl chloride is formed as a reaction intermediate. So statement 1 is correct. Statement 2, the electrophile in coal-base reaction is dichlorocarbene. Wrong. What is the electrophile in coal-base reaction? Electrophile in coal-base reaction is carbon dioxide. Carbon dioxide is acts as weak electrophile in coal-base reaction. Weak electrophile reaction. Thank you.